The International Space Station is a laboratory that orbits the Earth once every 90 minutes. It's the most expensive single project ever constructed. Jointly owned and operated by the United States, Russia, Europe, Japan and Canada, the ISS is a triumph of international collaboration. But it didn't start that way. And during its planning phase, it came close to being dumped.
Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
It was 1984, toward the end of the Cold War, when President Ronald Reagan unveiled his plan before the Congress. It was soon called Space Station Freedom, but details were sketchy and plans kept changing. NASA saw a space station as their next logical step. The Space Shuttle had been designed with on-orbit construction as one of its primary functions. On a cold morning in January 1986, the Space Shuttle Challenger was being prepared for its 10th flight.
And liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Challenger, go with throttle up.
Challenger, go with throttle up.
All 7 astronauts were killed, and the shuttle program was suspended. Just 1 month later, cosmonauts began occupation of Mir, the new Soviet space station. The Soviet Union had a long-standing interest in extended duration space flights with its Salyut space stations. And with Mir, the Russians were gaining valuable experience in microgravity research and on-orbit construction. As the 80s progressed, Mir expanded using modular fabrication techniques. They began experimentation with automated docking systems. New modules were delivered by the Proton launcher with the Progress cargo ship used for resupply. NASA's shuttle fleet remained grounded, while an exhaustive inquiry was conducted, and Space Station Freedom was stuck on the drawing board. In 1989, discontent in Poland spread across the Eastern Bloc, leading to the fall of the wall that had divided Germany. 2 years later, the Soviet Union itself was dissolved, followed by social and economic turmoil. Moscow was now the capital of the Russian Federation, a one-party democracy. The Mir crew EO-10 arrived at the space station as Soviet citizens and would return to the ground as Russians. The country's new space agency, Roscosmos, had had its budget slashed by 80%, and there was no money to launch 2 newly completed modules. In 1988, NASA had resumed shuttle flights. But with the fall of the Soviet Union, interest among US politicians in Space Station Freedom was at an all-time low.
Roger, roll, Discovery.
NASA now began working with Roscosmos. In the Shuttle Mir program, the Russians would benefit from an injection of badly needed funds, and the Americans would gain expertise in long-duration spaceflight. Astronauts learned Russian and began riding to orbit in the Soyuz. Cosmonauts learned English. During the program, 10 cosmonauts flew on the space shuttle, and 8 Americans served as crew members aboard Mir, with the shuttle docking with the Russian space station 9 times. Roscosmos had begun work on a replacement Mir 2 project, completing the functional cargo block and the DOS-8 habitation module, but lack of funding forced the agency to shelve the plan. NASA convinced the cash-strapped Russian Federation to come in on their project. Europe, Japan and Canada were also involved in what was now called the International Space Station. The functional cargo block was renamed Zarya and became the first piece of the International Space Station delivered to orbit in November 1998. Zarya was launched from Kazakhstan with an orbital inclination of around 50 degrees. This set the orbit for the International Space Station. The Space Shuttle would deliver the bulk of the modules from here on. NASA knew that this orbit would give the shuttle problems. Launched from Florida, the shuttle usually orbited at 30 degrees. To reach the steeper inclination with any meaningful payload, the shuttle needed more power, or it had to lose weight. A redesign of the cargo bay delivered some weight savings, but the construction missions could only be achieved with a new external tank made from a new lightweight alloy.
We have a go for main engine start. We have main engine start. 4, 3, 2, 1. We have booster ignition and liftoff of the Space Shuttle Endeavour with the first American element of...
2 weeks after the launch of Zarya, the Space Shuttle Endeavour lifted the Unity node to orbit.
Houston's now controlling. Endeavour's rolling on a course heading northeast from the Kennedy Space Center toward a 240-mile-high rendezvous with the Zarya control module.
In preparation, the crew connected the Unity node to the shuttle's airlock, and using the shuttle's robotic arm, they united the 2 modules. The crew entered the space station for the first time and stowed equipment, but no one would take up residence just yet. Construction work had just started. It was 18 months before the arrival of the next module, Zvezda, the Russian habitation module. It docked automatically with the Zarya module. In October 2000, the Space Shuttle Discovery arrived with more pieces. During 4 spacewalks, the crew installed a structural truss and communications equipment. Finally, in November 2000, the first crew, Expedition 1, launched from Baikonur. Cosmonaut Yuri Gidzenko was commander of the Soyuz spacecraft. Astronaut Bill Shepard was the commander of the team once they were on the International Space Station, and Sergei Krikalev, the most experienced member of the crew, was flight engineer. Much of the crew's daily activity was devoted to the unpacking and installation of equipment. There are always problems that need to be solved and maintenance to be carried out. In microgravity, muscles lose tone. One of the first pieces of equipment to be set up was an exercise bike. Every crew member is required to do 2.5 hours of cardio exertion every day. Unlike later missions, Expedition 1 carried out very little scientific research. At this stage, the station's primary laboratory module was still on the ground. But that would soon change. The crew of the space shuttle Atlantis delivered the laboratory module called Destiny. It was a radical increase in capability for the space station. The laboratory is equipped with 13 international standard payload racks that can house a variety of different experiment modules, but at this stage they were empty. With the Destiny module and a new, much larger solar array, the International Space Station was taking shape. a precisely organized launch schedule was unfolding, and it was expected that the space station would be complete by 2006. In November of 2002, the Space Shuttle Endeavour took off, carrying the Expedition 6 crew, plus a new piece of the space station's superstructure and 2 tons of supplies. Returning to the ground, no one realized that it would be the last time a cosmonaut would fly on the shuttle, and that construction work on the ISS would be suspended for more than 2 years.
Columbia, Houston, comm check.
When the Space Shuttle Columbia broke up during re-entry to the Earth's atmosphere, all remaining shuttles were grounded.
Columbia, Houston, UHF, comm check.
81 seconds after launch, foam insulation separating from the external tank had damaged the left wing, and from that point, Columbia was doomed. The investigation board had no confidence that the entire space shuttle fleet could be safely operated for more than a few years, calling the shuttle an aging spacecraft. With shuttle flights suspended, construction work on the International Space Station stopped. Replacement crews were cut to 2 members. The Russian Progress freighter was the only method of delivering supplies to the ISS, and all crew rotations used the Soyuz spacecraft.
Принято 30 секунд, на борту порядок.
What started out as America's space station freedom was now completely reliant upon Russian technology. It would be more than 3 years before construction work on the space station recommenced. In 2004, US President George Bush made a speech to an assembled group of NASA administrators.
Our first goal is to complete the International Space Station by 2010. In 2010, the Space Shuttle, after nearly 30 years of duty, will be retired from service.
The Space Shuttle would be restricted to work on the International Space Station, where the crew could await rescue if their craft sustained damage. Scientific work was cut to a minimum, with the small crews preoccupied with station maintenance. Fabrication work on the modules continued on the ground. The Space Shuttle Discovery made the return-to-flight mission in 2005. Before docking with the International Space Station, it performed the rendezvous pitch maneuver, allowing the ISS crew to inspect the craft for damage. It delivered supplies and equipment and returned safely to the ground. Atlantis arrived 14 months later, and after a break of almost 4 years, construction work began again. In what became known to NASA astronauts as the Wall of EVA, that's extravehicular activity, it took 14 more shuttle assembly flights to bring the ISS to its current configuration. If just one of the installation's spacewalks was to fail, it could threaten the entire project. The schedule was relentless because the shuttle's days were numbered. Training for these assembly missions was intense. NASA's neutral buoyancy laboratory was rigged with a mock-up of the ISS, so astronauts could experience something akin to weightlessness while they practiced. In July 2011, Atlantis flew to the ISS on what was the final flight of the shuttle fleet. The International Space Station was essentially complete, although it continues to be reconfigured and new pieces can still be added. Its 16 pressurized modules have a volume equivalent to a 5-room house, including laboratories, storage spaces, and habitation areas. Power comes from 8 solar array wings, which track the sun. When the ISS enters the Earth's shadow, the solar wings enter night glider mode, where they are angled edge-on to the orbital direction. Though the ISS orbits 400 kilometers above the Earth's surface, there is enough thin atmosphere at that height to present drag. Night glider mode reduces this drag and minimizes orbital decay. Supplies of water, oxygen, food and equipment are regularly delivered by unmanned cargo craft. Most frequent of these has been the Russian Progress, which is similar in appearance to the Soyuz. It docks by itself using the automated Kurs system. It can also be docked manually if the need should arise. Like the Soyuz capsule, the Progress freighter will remain docked long-term. As well as delivering supplies, it can boost the station's orbit, or it can transfer fuel for the station's thrusters. Ultimately, filled with garbage, it undocks to burn up in the atmosphere. The Japanese space agency, JAXA, currently operates the largest cargo craft that still visits the ISS. To dock with the space station, it approaches in stages until it's close enough to be grabbed by the robotic arm and connected to one of the berths on the Harmony node. It has a pressurized zone that can be unloaded by hand, and there's an unpressurized area, accessed by the robotic arm, for cargo to be stored on pallets outside. With the demise of the space shuttle, NASA has turned to the private sector to fulfill its resupply commitments. The Cygnus freighter first visited the ISS in 2014. The SpaceX Dragon cargo craft first delivered supplies to the ISS in 2012. It is different from the other cargo craft in that it can return significant loads back to the ground. Experimental materials from the ISS can be in an Earth-based laboratory within 2 days of leaving low Earth orbit. SpaceX is developing a Dragon capable of carrying astronauts to low Earth orbit. The business of the International Space Station is research. The study of fluid dynamics and material science in a microgravity environment simply cannot be done on the ground, and the orbiting platform is the perfect place for Earth observation, meteorological studies, and astronomy. The study of plant development in microgravity is of great interest. One of the major areas of study is into the effects of prolonged weightlessness on the human body. Without the resistance provided by gravity, muscles and bone deteriorate. This is partially offset by regular exercise. The ISS is equipped with a treadmill, a cycle ergometer, and a resistive exercise device. All are shock-mounted so as not to pass vibration across the station. The loss of bone mass shows up as raised calcium levels in the blood. Blood samples are taken regularly and stored at low temperature for later analysis. The extra calcium can lead to kidney stones. NASA and JAXA are cooperating in the study of an agent that can prevent these effects. Most astronauts on long-term missions complain about deterioration in their vision, which can persist for years after a flight. Distinct changes to the eye have been detected, and ultrasound examinations of the eyes are done regularly. Astronauts and cosmonauts are totally reliant upon the technology of the ISS, and it needs regular maintenance. In August 2018, a small but steady drop in air pressure was noticed. It was traced to the Soyuz MS-9 capsule. A 2mm hole appeared to have been deliberately drilled, and nasty rumors about sabotage began to spread. Cosmonaut Sergei Prokopyev made a recording from the Soyuz to show the repairs and to quash stories about poor morale on the space station.
As you see, everything is calm. We're living in harmony as always, and all the experiments are going to plan.
Later, it was decided that a spacewalk to cut away some of the external insulation from the Soyuz above the hull might deliver more clues about how the hull could have been made. Because the Soyuz capsule is not designed for external maintenance and lacks handrails, it was a challenging job for the cosmonauts. It was difficult slicing through the 8 layers of the thermal blanket used to stabilize internal temperatures on the spacecraft. From the inside, it appeared that the hole had been repaired with glue, which gave out after the Soyuz had docked with the ISS. It was thought that analysis of the glue would shed more light on the mystery. Because the hole was in the habitation module, it was no threat to the craft's safe return. The blanket, which was left in a mess, is also not required during re-entry. Russian cosmonaut Sergei Prokopyev, European astronaut Alexander Gerst, and American astronaut Serena Agnon-Chancellor had flown up on this spacecraft and would be returning home on it.
The visible portion.
When maintenance or repair work has to be done outside the ISS on NASA, ESA or JAXA modules, the crew members with the required expertise have training in the use of the American spacesuit, known as the EMU. Some crew members have training on the EMU and the Russian all-land spacesuit. Those with experience in both say that the American suit is more flexible and comfortable, yet it is very complex and takes a very long time to put on. By contrast, the Russian suit is simple to put on and is designed to be easily serviced by cosmonauts. Even the smallest equipment malfunction can be life-threatening. When ESA astronaut Luca Parmitano was installing cables outside the ISS, water started leaking into his helmet.
I feel a lot of water on the back of my head, but I don't think it's leaked from my back.
Are you sweating? Are you working hard?
I am sweating, but it feels like a lot of water.
Mission Control called him back inside, but by the time he had reached the airlock, he couldn't see and he couldn't hear. His colleagues quickly got him inside and removed his helmet, along with more than a liter of water. Later, the empty suit was powered up and the fault was obvious. The water was leaking from the suit's cooling system. A report blamed Mission Control, who assumed that the water was coming from the in-suit drinking water bag. A crew will typically stay in orbit for around 6 months. The arrival of a new crew means that for 3 other crew members, their stay is coming to an end. They board the same Soyuz craft in which they traveled to orbit for the return to the surface. Undocking of the capsule is precisely timed. It separates initially by the spring mechanism in the docking interface. Only at a safe distance from the ISS will the Soyuz make the first of its separation burns to avoid contaminating the space station. At a point in the orbit opposite to their intended landing area, the retroburn happens, slowing the craft for its descent into the atmosphere. This burn is precisely timed and lasts 4 minutes and 45 seconds. At this stage, the descent capsule is still attached to the habitation and instrument modules. In Kazakhstan, a fleet of ground vehicles are heading for the landing zone. Medical teams and recovery personnel from Roscosmos, NASA and ESA are also in the air. Explosive bolts fire to separate the 3 parts of the Soyuz. During the heat of re-entry, the crew are out of radio contact with the ground. In the upper atmosphere, the drogue chute deploys, further slowing the capsule. And then the main chute. On the ground, the crew are lifted from the capsule. They're experiencing gravity for the first time in months, and it will take them months to return to normal. They are carried through the snow and will soon return to their homes.